By now you should have all the necessary skills to tackle differential equations, finding a general solution, particular solution, and so on. One of the main applications is we can model a problem, real-world problem, perhaps by differential equations, and then we will need to solve it and use that model later. So there are a few steps you can look at. You should consider while you're solving differential equation problem. I'll look at a couple of examples, but we'll discuss the step first. So maybe you can begin by defining all the initial values, read between the lines of the problem, and including boundary values. Talk about that during one of the examples, and then you should also then solve the differential equations. Solve differential equations, and then use the initial values that you discover in the first step to find all constants if possible. Then scan further. Perhaps you need to solve further problems, and so use the solution or the model that you got after step 3 to solve those problems. Okay, let's look at the first example, very straightforward one. And this is a very straightforward problem, but we follow the steps again. So the first, look for the initial conditions. Read carefully, you can see this is it. So write down the initial conditions. So after you have determined the initial conditions, then the task is to try to resolve this model, the differential equation. So let's try and do that. So here's your model, and it can be separated like this. And so performing integrations on both sides, we should get the solution, general solution as follows. But because we have this initial conditions discovered earlier, so sub this into here to find the value of C, and we should get C equivalent to, so we'll get this C value. Don't need to try and use calculator, just leave it as ln 25,000 first. So substitute now C value back into the general solution. We'll have this. Of course, we can further simplify this using a rule of log. We can merge these two terms, and the 20 be left alone. Then we'll get n be this simplify as follow. And of course, then we already have the particular solution away. But now we are being asked to find a value of m when n is provided. So we'll now use this solution to help us. So we'll move on to here. So we have this substitute n equals to 100. And now I can actually do away with the absolute sign. Think about this, because 25,000 clearly is a positive number, and the variable m is about income of people. So while income is positive, so we can just, in practical sense, in the particular context, we can just ignore the absolute sign and just leave with 25,000 over m. And so let's perform the manipulations. You arrive here, and in the end you get m equivalent to 25,000. E to power -50, and now use a calculator. You should get approximately 4.82 in the standard form, 10 to the power of -18, and the unit should be m, should be dollar, I think. Yeah. So the problem solving, firstly must identify all initial conditions or the boundary values, and then solve the model to get the general solution, and then use the initial conditions to find the particular solution. That's very important. So if there's a further problem that requires you to settle, just go ahead, use the solutions, and do the proper workings, and you get what you require. Now let's look at another second example, something that's more challenging than this example now. Now this is a much more complicated questions, but the step will still be the same, but first notice that there's it should be g minus 4v here, Anyway, now the first step is of course to find the initial conditions or the boundary values, wherever that is, you need to find it. So read carefully, and you probably realize then after taking some time to read it through that yes, here it says the metal was released from rest. That means velocity is 0 in water at the beginning. In other words, this means that when time is actually 0, velocity is actually 0 also. So now we can proceed to resolve this differential equations to get what is required in part A. Now let's try and do that now. Now you probably recall that this is a separable differential equations. Clearly we can express them like this, dv, and this side would be dt, the right hand side. And if you perform the integrations both sides, you end up getting -1/4 ln g minus 4v. Recall that the g is actually a constant, but focus on this now. So plus, say, c. So perform some algebraic manipulation, you will get this. And of course, here is really, you can write this as e, or rather a, e to power -4t. If we take, by letting a be equivalent to e to power of -4c, c, we recall is just a constant. So now rearranging this, you end up writing v as the subject, and because of initial conditions that VO equals to 0, we can now sub that in. The VO is actually equal to 0, means T is 0. You see A here, this is 4, and finally you get A equivalent to this is G, and replacing A by with G, you have shown that this is indeed true. And then we need to use this model, the answer that we obtain, to find out more about this. Well, show that there is limiting velocity. So the idea is that e to power of a positive number would tend to 0 when a tends to really huge, is a concept that you must recall. So with that in mind, you can see that when t tends to infinity, so this term e to power -4t would approach 0. So in other words, we have v from here, okay, from the solution. So we're going to replace this by 0 when, because assume that t tends to infinity, we'll have g over 4. So that would be the limiting value. Of course, it should be meter per second. So that's your limiting value, and this concept is very important. So please try to remember this, or at least must understand why this is so. And there's one more part B. Where is the metal falling at g over 10 meter per second? That would be very straightforward problem. Just substitute this g over 10 into the solution that we obtain. So when given that v is equal to g over 10, equate this to this, and our aim is to find the value of t. We would proceed to get this and perform the algebraic manipulations, and finally you should see something like this, 4t equal to 305, and then you would get t equivalent to an exact value -1/4 ln 305. Of course, you can leave it as such, or just take approximated value of 0.128 second. So this is exact answer, and this is the approximate answer to three significant figures.